All right, cool. Evening, everyone. How are you all doing?
You're cloning yourself already.
I'm Steve Schneider. I'm the President and CEO of the Fleet Science Center here in San Diego. Let me welcome you to the beautiful city of San Diego. And Comic-Con, if you haven't been formally welcomed yet, welcome. We'll apologize for the weather because that's what we do here. I heard it was 73 this afternoon, and so we apologize for it not being quite 72 all the time. But welcome for our panel on OSHA violations to superhero lab accidents that will most likely give you superpowers. Big spoiler, they won't. Nonetheless, we've got a panel of distinguished folks here with lots of great lab experience, some really fun and interesting and cautionary lab accident stories, and we're going to talk a little bit about their experiences, what they would do to kind of take them into superpowers, and about all sorts of cool science stuff. We'll have time for some questions, certainly, so think them up. But when you do come up and ask questions, we want to hear what you think their lab accidents would be in terms of superpowers. So think creatively as well. All right, so let me introduce the panel to you. Follow my list and who's here. Okay, directly to my left, we have Robin Gunn. She is a PhD, senior scientist and project manager at structure-based design. She works with Synchrotrons during the day. At night, she goes by her other moniker, Robin X-Ray Gunn, crystallographer extreme. Next to her, we have Michelle Nolasco, PhD. She started her career as a molecular biologist in R&D. She's worked at a number of biotech companies on gene therapy applications, RNA processing, mutation chloroplasts. There's a mouthful for you, huh? She could explain it all to you. And a number of other great things, but of course we all know her as the spectrometer. Then we have Sierra Simpson. She's a PhD candidate in molecular neuroscience at Scripps Research. She studies the gut-brain axis and the intersection of the microbiome and opioid addiction. That's your poop to your brain and everything in between. But she is Captain Neuron.
Captain Neuron.
All right. Then we have Alex Phd. She is a PhD candidate from Columbia University. Now working up here in La Jolla, specializes in fusion energy, our very own Dr. Fusion, Mr. Plasma. Alex, welcome, Alex. We have Todd Maxwell, who's going to keep us all in reality. He is the radiation safety officer at Scripps Research, otherwise known as the regulator. And finally, we have Dina Zangwill. She is a research assistant at Salk Institute for Biological Sciences. I'm going to let her tell you what she does, because it's cool and icky at the same time, which is how you know it's cool, our own Dr. Disease. So welcome to the panel. And welcome you all for being here. Thanks for being here. Let's kick this right off. I'm going to turn it right over to Robin. Tell us about your lab experiences and potential accidents that could happen. Take it away.
Hi, everybody. Oh, hello. So I'm Dr. Robin Gunn, or X-Ray Gunn. And so I think one of the best places to get superpowers is actually at an X-ray synchrotron facility. And so a couple of them are called like the advanced photon source or the advanced light source. And this is where, so I'm a protein X-ray crystallographer, and this is where I would go and collect my data in order to figure out how atoms are arranged in space to solve protein structures. And so synchrotrons are these really large campuses, generally government facilities, and it's a really super geeky, weird place. It's really a surreal experience to go there. So they're on their own campus, and they have guards with gated entries, and there's this enormous circular building, concrete, and they're so big that to get to the other side of it, they're circular. You have to like ride a tricycle to get all the way around. And at each point along the ring, they call it, there are different hutches, experimental setups. And it operates 24 hours a day. So, you're in there in the middle of the night collecting your data set. Scientists are coming out of like places that things are covered in tinfoil, and there's really high energy physics and x-rays going everywhere. So while I was a graduate student, we actually had to physically go to the beamline. Now there's a lot of robotics, and I can ship my crystals and collect remotely from here. But so The actual accidents that would happen with big X-rays at a synchrotron would, rather than giving you superpowers, would probably make you super dead. And you can't see the beam with your eyes. So these experiments take place in these lead-shielded rooms, and there are a lot of safety precautions in place so that you don't get hurt. So generally, you have to go in and you would press a big red button, and then lights flash in the room, and it says warning, 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 and then you go outside, and you have to pull this big lead door closed and lock it, and then you have to take, 2 people have to go take a key and turn it simultaneously. Like this really, literally, that's what you have to do. And I would do that hundreds of times a night as you're looking for crystals to collect data on. So anyways, they have this double key system, so there's a lot of mechanisms so that you don't get hurt. So what can actually get in and out of the hutch, though, are critters. So ants, I've seen all kinds of things at the beamlines. They had a bird problem at the Advanced Photon Source for a while. Ants, so that's why I was thinking I would get, because if you were to get shot with X-rays, that wouldn't be great. You need kind of a microdose to get superpowers. So I'm thinking these animals go in and out, and that's how I'm gonna get my superpowers.
So it's them made real, right? This is what's going to happen. So do the ants get hit with X-rays? What happens to an ant?
Well, I don't know, but I do know that one night when the beam was down, somebody said, "Did you know if you microwave an ant, they don't die?" And so we tested that. It's true. You can all go home and do it. But I don't think it was something special about the synchrotron that they lived at the synchrotron, but maybe, I don't know.
So there you go. There's your superpowered ants. Synchrotron ants, right? Didn't have anything to do with the experiment, right?
Most people would say, don't try this at home.
Particularly if you're an ant. All right, Michelle.
Get closer. Robin was talking about how creatures get involved in her science, and the accident I'm thinking about actually focuses on creatures, specifically mice. So I worked at this biotech, and we had a vivarium, and we had lots of different strains of mice. And one day, even though there are a lot of procedures about the right way to do it, some cages didn't quite get closed completely. And then later on that evening, apparently one strain of mouse met up with another strain of mouse, and a few weeks later, we had some unexpected litters of cute little tiny mice. And as they grew up, we realized, oh, these little pups don't look like any of the other strains we have. They were kind of these hybrid-looking mice. So we couldn't use them for the research, but that meant we got to take them home as pets. So I had my little mice, and I had them at my house, and they were super cute and so sweet, and sometimes they'd wake me up in the middle of the night with their little mice antics scurrying about. But then I was thinking, okay, well, why did we have these mice? Why did we have this vivarium? And what we were actually doing was looking for cancer treatments. So we had these mice, and we'd put a few tumor cells into them, and then we'd have a treatment, and then we'd check, well, did the tumor continue to grow? Did it stop growing, or did it start to regress? So that's a really specific outcome that we were looking for. So what was this treatment? Well, it turns out that this pathogenic bacteria called Mycobacterium tuberculosis, yes, it causes TB. If you introduce that into a mouse that already has a growing tumor, sometimes that tumor will regress. So you've got a mouse with cancer, had a pathogenic microbe, and sometimes it turns out okay, right? So my part of it was manipulating the genes. It's kind of scary to have live TB around and injecting it into different animals and in the lab. So we decided, well, if we just take a part of it, what are the proteins that are actually causing this regression to happen? So we genetically engineered these genes to create a protein So I had a lot of hands-on genetic manipulation, and then the same thing. We'd grow up the tumors in the little mice and inject these proteins into it to see if the tumor grew, stayed the same, or regressed. So I was thinking, I have these mice at home, and they are the offspring of a mouse that had actively growing tumor that was then introduced with a genetically manipulated construct from a pathogenic microbe. So what was actually happening at my house at night? Were they just scampering about, or did they have some kind of superhero kind of power that they can overcome the tumor, overcome this microbe? And not to mention, they had already been crossbred, right? So imagine, if you will, what kind of superhero or super sidekick or super villain might come from that kind of setup. So that's my potential superhero sidekick.
And of course, I'd argue that the mouse did create those offspring must have had a superpower because they escaped from the lab into your home.
Right.
So I don't know if it was superpower there, but maybe, if you're thinking about cheese a lot, it might be time to be concerned. All right, Sierra.
Great. So I like to talk about neuroscience in kind of a way where when I go to work, it kind of feels like Resident Evil sometimes. We use viruses all the time to manipulate neurons, and basically these viruses, they go in the neurons and they can express all these different proteins, whatever kind of protein you want and you can think of, these viruses can do. And so there were 2 experimenters in the lab who were trying to express a protein that would stop an animal from coughing, because in some patients that have cancer in their lungs, they cough a lot, and it's really horrible for them. So we were trying to aspirate this virus, and you're supposed to do it in a hood. But not every scientist is very careful, and we need good safety people to tell us what to do and what not to do. So if you're not careful, the virus could go up into the air and you could inhale it, but it might impart some magical things into your lungs where you could breathe underwater or prevent getting sick from a toxic cloud, because now your lungs have these special proteins in them. And where I work is at the intersection of the microbiome and where your gut basically controls your behavior. At least this is a new growing field. They call me Captain Poop at work, not Captain Neuron, because I'm always getting poop from animals. But you can imagine culturing like a big thing of bacteria and it ends up spilling on you. And maybe it binds with your DNA and then you can actually send out bacteria to other people and then control their minds using your bacteria. So that's my lab accident.
You're not really trying to do that, are you?
Ooh, applause.
Right. Alex.
Hello, everyone. So I decided to go with a little more historical lab accident that I was not personally there for. It comes from the 1940s when the United States government was attempting to harness recent discoveries in quantum and nuclear physics to make a fission bomb to hopefully help them win the Second World War. And in doing so, they created 3 14-pound plutonium cores. And all 3 of these cores ended up having a pretty interesting story behind them. The first was put into a device that was used during the Trinity nuclear test, which was a demonstration of the first ever nuclear explosion. You might have seen the video of that. The second was put into a device that was detonated over Nagasaki, Japan. And the third was being developed into a third bomb, but that was canceled because the Japanese surrendered 3 days before its scheduled drop. So we were very close to a third nuclear bomb over Japan. And when they decommissioned this plutonium core, they decided they wanted to use it for experiments at Los Alamos National Laboratory in New Mexico to study. So all these cores were designed with very low safety margins to guarantee that if you added any more additional matter to them, that they would detonate. So that's called going supercritical. And so the physics behind that is when you take a very large atom like uranium or plutonium and you hit that atom with a neutron, it'll split or fission into 2 smaller atoms and release a large amount of energy, as well as 2 to 3 neutrons. And those neutrons can go on to find other heavy atoms and split them. And that makes an exponential release of energy potentially. So if you have enough of a fissionable material in a given volume, it will spontaneously explode. So that's how a nuclear device works. You just add more material. You would like fuse two materials and get the right size. So they were determining how close this core was to going supercritical. And to do that, they would do it by hand, which we would never do anymore. And I'll tell you why. And to do that, they would place the core on a table, and by hand, they would stack tungsten carbide bricks around it. And these bricks would reflect the neutrons back at the core. So it would lower the mass you would need to go supercritical. And one day, so you probably see where I'm going here.
Which again is a bad thing.
They needed him around a little more. So one day, someone was stacking a brick onto the stack there, and they noticed that that was one too many bricks. And they quickly went to remove the brick and dropped it directly onto the core. And the room filled with a bright blue light, and he felt a tingling sensation throughout his body, and that was because he was getting 500 rem of neutron and gamma radiation. And so that was a lethal dose, and that person ended up dying from that accident, so they launched an investigation at the lab, and then exactly 9 months later, the co-author of that investigation was doing the same experiment himself. But this time, he did it a little differently, and instead of doing bricks, he would have a large metal lid that he would hand lower over the core. And it was designed so that if it fell on the core, it would go supercritical. And this was so dangerous and stupid that in the lab they called it tickling the dragon's tail. Nobel Prize winning nuclear physicist Enrico Fermi was quoted saying, if they keep doing this, this guy's going to be dead in less than a year. And he was absolutely right. Because one day he was performing it for a group of visitors to the lab because they thought it was so cool. And he dropped it over the thing, and the room filled with bright blue light, and he got a lethal dose of ionizing radiation from that. In both cases, they were able to remove it quick enough to avoid a nuclear explosion, but not quickly enough to avoid the radiation dose. And an interesting fact is that bright blue light that was present in both accidents is called Cherenkov radiation, and that occurs when a particle, in this case a neutron created by the fission, moves faster than the speed of light in a medium. So it's analogous to a sonic boom, where if an object moves faster than the speed of sound, it will release pressure waves, but if an object moves faster than the speed of light in a medium, it will release this light blue light. And this could potentially give you superpowers, I'm thinking, because that is why Dr. Manhattan, the superhero, is light blue. It's because he's supposed to be emitting particles that are going faster than the speed of light. So after this, they made a new rule that every person has to be at least a quarter mile away from these experiments. And only robots are allowed to do them from now on. So.
You forgot to mention that they used the safety tool of a screwdriver
Yeah.
to help lift the lid, and that was
Oh my God.
the only device that they had.
He had a backup. If you dropped it, he had a screwdriver to catch it,
Yeah.
too. So. That's my story. Thank you.
Todd. But this whole time is going, oh.
The year was 1970. And the most important thing to happen that year was the very first Comic-Con. Another very important thing is that an organization called OSHA came into effect in the United States.
Applause for OSHA. We got that on tape, right? Awesome.
Before the Occupational Safety and Health Administration came along, employers weren't really required to provide a safe work environment for the people who worked for them. You could lose your arm in an accident, and it was pretty much considered an act of God, even though it was that person's machinery that pulled your arm off. There was no guarantee that you would keep your job, or in some cases, when you're working on a 10-story building and you fall off the top, oh well. And it was in 1970, and that might sound like a long time ago for some people, but in my lifetime, There was a time when people didn't have to take care of their employees. That's kind of scary. And certainly situations that occur today are much more regulated than they were in the past, and we do have safety things in place. But it wasn't until 1991 that OSHA enacted a laboratory safety standard, and that's not too long ago. Since 1970, you still had to protect your employees, but in a laboratory, the risks are a lot different. When you talk about things that might cause cancer 20 years later, there really wasn't anything in place to protect employees from that sort of thing. So gives you some idea of the time frame of safety in laboratories. It was also in 1970 that my story took place, and this is a real-life story. This is kind of a real-life superhero as well. In 1970, a man named Dr. Sharples was working in a chemistry laboratory at MIT. It was towards the end of the day, and he was ready to go home, and so he wasn't wearing any safety equipment, but as he's walking out, he sees a coworker working at the bench. He says, "How's it going?" The guy says, "Yeah, I'm finishing up this experiment. It should be ready tomorrow." He walked over to the experiment, picked up the glass tube, held it to the light, and it exploded in his hands. And I'm going to read part of this story that he wrote to us as he now works at the Scripps Research Institute where I do. And he gave us this story so that we could use to tell new employees how important it is to wear things like safety glasses and so forth. So I'm going to read a short paragraph here of what he wrote. My coworker was flame sealing an NMR tube at atmospheric pressure in a big nitrogen bath, a procedure the two of us had discussed before, but neither of us had actually performed. I stopped by his bench, picked up the tube from the bath, and held it to the light. I noticed that the solvent level was exceedingly high, and suddenly the solvent level dropped to a normal level. Though I instantly realized condensed oxygen had been sealed in the NMR tube, I was quite literally unable to move a muscle before it exploded. Glass fragments shredded the cornea, penetrated the iris, and caused the partial collapse of one eye. My other injuries were superficial cuts to the face. He spent the next 10 days in the hospital, not knowing whether he would regain any eyesight, because severe damage to one eye can affect the eyesight in the other eye. He was fortunate that didn't happen. I tell this story because there is a happy ending, although it sounds a little bit like a Daredevil story, and Matt Murdock getting hit by radioactive isotope and losing his eyesight. Dr. Barry Sharples won the Nobel Prize in 2001. Now, some of you might think, well, he was a pretty smart guy and he just happened to have an accident and was able to overcome that. But the comic book person in me likes to think that maybe it was the accident that made him so smart. So maybe there was something in that NMR tube that penetrated his body and allowed his brain to, pardon the expression, have better vision of chemistry. The Nobel Prize he was given was for something called, and I have to read this because it's outside my pay level, chirally catalyzed oxidation reactions. And just to give you a little bit of the chemistry here, molecules can have the exact same chemical form but be actually mirror images. If you think of your hands, they look exactly the same. They've got the same makeup, 5 fingers and so forth, but they don't really fit into the exact same physical space. So when you do a lot of synthesis, all you get is the left-handed molecule, and sometimes you really need the right-handed molecule. And so he developed a way for certain chemicals to be able to do that and produce the one that is more beneficial. And the difference between the two can be something giving a positive effect and something killing, a cell. So just because of the physical way that it meshes with the cell. So there's a real-life story, and I like to think of him as a superhero, although when you talk to some of his postdocs, they might consider him a supervillain. But it makes you think about science and experiments, and there are plenty of ways that you could go from that. NMR uses large magnets. It involve how that developed magnetic powers or laser vision or any of the things that we see in comic books today could have been generated by a similar type of basic experiment. So that's my story, and I'm sticking to it.
Dina.
So Dr. Sharples kind of sounds like a comic book scientist name a little bit, doesn't it? So you've already heard someone mention virus already, and I'm going to preface this by saying there hasn't been an accident with this. I haven't had an accident with the virus, but I work with virus as well. And previously was mentioned using virus to introduce genes into neurons. What I do is I use virus to turn other cells into the neurons before we introduce virus to them again. So we do it twice. So one of the things is that I make virus that introduces proneuronal transcription factors into human cells. What these do is you can activate these transcription factors, and these are factors in the genes that will then unlock other genes. So we're giving genes to unlock genes that already exist in the cell that will turn the cell into a neuron. What we use are skin cells. So what if you got exposed to this virus? Would you start growing brains all over your body? And
Yes, I would.
absolutely. Think that'd be a really great way to make a super genius. Just get some extra brain power. You have lots of skin, right? You have skin to spare. And in addition, we introducing virus. Once the neurons are made, we want to see how they're working. So we give them more virus so that they glow different colors when they do different activities. Like when the neurons firing, when a neuron fires, we can get them to glow green with a green fluorescence protein. And it actually is when neurons fire with, one of the things they fire with are calcium channels. You also fire calcium channels when you flex your muscles or you get scared. So if you got that virus, would you glow when you exercise?
I do.
Have any of you, and if you're thinking, that's not a really cool superpower, have any of you seen the movie Sky High? Don't you remember the human glow stick? So that exists. Maybe I've accidentally been exposed. Maybe I do glow. I have not.
All right. Thank you, Dina. So I got a couple of questions just to throw back to the panel here. So one of the things a lot of people talked about is this notion of a virus, right? So it's just thinking about the notion of safety in a virus. One of the things we often hear, one of the other stories are taken, okay, there's a virus that gets out and that's the end, it wipes out the world. The viruses you guys are playing with the lab, they're going to get out and...
We use non-replicative viruses. They require a lot of virus parts to make it actually function in the dish. So it's not going to crawl out of the lab and infect everybody, hopefully.
So the replication deficient viruses like to put their genes into our cells and get our cells to make more virus. We've taken out those genes and put in the ones that we want. So they don't have those anymore. They can't make any more virus. The danger is only to us who are handling it.
So, okay. So, in
So
other
we're
words,
the ones who are going to get the
We're
powers.
safe. You're going to be the superheroes or supervillains, right?
Todd tells us what not to do.
Thank you, Tom.
So, a question.
I think every lab safety rule comes from having had an accident.
Yeah, definitely.
That precipitated that rule. Yes.
I can remember back in the day when I was a scientist, I was in accelerator physics, and my advisor, who was blind. So you want to talk about Daredevil? Yes. Except he couldn't do stunts or karate or any of that stuff. He could do calculus in his head. You'd explain a graph to him, he couldn't see, and you go, no, it goes like this, doesn't it?
That is a
You're right.
superpower.
Anyway, so there was a superpower in itself. But he would tell stories that in the old days when they were first building cyclotrons, because he was there, they'd have the cyclotron, they'd have a target, and there would be the beam in the middle of the lab. And so you could know, if you ran into folks, you would know whether they worked at that time because they would have scars across their shoulders because you would accidentally walk through the beam because you couldn't see it.
Right.
But it could see you.
And they were usually missing a finger or two.
Right.
So certainly. So that's a question for the kind of the safety procedures. Is that really where it goes at this point? We wait till something bad happens and then we fix it, or are we a little more proactive now? Let's hope.
Unfortunately, nobody ever plans for every possible contingency, and it is usually an accident that occurs that, we thought about this, we thought about that, we just didn't think about this. And then things change,
So
usually very quickly, and countrywide or worldwide, once an accident occurs, people are pretty good about then addressing it, but it's unfortunate.
So we'll only have one set of superpowered ants, and then, okay. So there was a lot of talk about mice and mice escaping. So how often does that happen? How often does a mice make it out?
More than we would like to admit.
On that one.
Small and
Yeah,
wily.
they're little. They're so little.
They're so little.
They get into place.
And when they're like 12 days old, they go into this thing that we call popcorn stage. Scientists have all these weird, funny names for things, but basically, they just pop up and down in the cage when you open them, and guaranteed the one you need is gonna fly out, and you're gonna be on the ground in your lab coat trying to find this mouse in a dark room because the light cycle's the wrong one.
And that's something else about vivariums is that they have all these regulations around them, including things like the light cycle. So how many hours of light, how many hours of dark, temperature, noise level, odor level. So it's all about making these animals that we learn so much from really, really happy. And in my lab accident, I like to think our mice were really, really happy because even though they escaped, which was not the best, they found each other and they procreated and they had viable offspring, which are all great things in the science world. So something good actually came from that lab accident.
Well, I thought you said that some people took some of those offspring home to their snakes.
Oh yeah, that happened too.
I don't think those were the happy ones.
Those were the less happy ones.
Happy ending.
We called
for the
them
snake.
mousicles.
So in the end, it was less a superhero story than a love story.
A little bit, maybe. I guess
Okay,
you could think
love
about
story
that.
comic. All right, they have those two. That'd
but
work.
I prefer if a story is a love story, if there's at least one good fight scene. So maybe you guys can like come up with another little introduction of a supervillain to have a fight scene in my love story.
Supervillain's a cat.
Oh, there we go.
So one of the other things that just in all of this, we talk about these lab accidents. We talk about how they might, give us superpowers, whether a spider bite. Although I heard somebody has a spider bite.
Spider bite last night. Last night, right here on my arm. Spider bite.
So if you find her later,
We're keeping an eye on her.
She'll be glowing.
That's right. But we talk about all of these things, the notion of these accidents giving superpowers. I guess, and yes, it's cheesy, but I'm from a science center, so I have to do this. The stuff you guys doing is freaking awesome. I mean, nothing against Tony Stark, but seriously. So I just thinking about any of the stuff that you're doing. I mean, thinking about again, this idea of X-ray crystallography. I mean, think about, explain what you're actually doing, the scale of what you're able to see.
Yeah, so when I do X-ray crystallography, I'm actually able to determine where every atom is in a protein. And so proteins are the things in your body they're the machines. They do everything. They catalyze every reaction. They do everything for you. So I was actually thinking that in my accident, the superpower I would like would be to be able to see electron density. So to be able to see, so I wouldn't have to go to the synchrotron to do my experiment. I would just see it, right? So after I win my Nobel Prize, because I could solve any protein structure I wanted. You know, it would be really interesting to be able to do like precision medicine, you know, to be able to look in somebody's body and actually make the changes that need to be changed to cure a disease. So to just be able to see at atomic resolution everything that's going on.
And if you were a supervillain with that power, what
What's
would you
that?
use that? If you were a supervillain,
Oh. Well, I mean, I could definitely assassinate anybody I wanted.
Really nice to her.
And I mean, but then also, I mean, the superpower is not, that's just an exaggeration of the power that we really already have, which is to be able to go to the synchrotron, collect this data, and be able to solve structures of these proteins and look at their active site and design better compounds and better drugs to bind them to cure diseases. I mean, we are doing that in reality. My superpower vision is just to be able to like do that with my eyeballs and like not have to have all these layers of data collection and math. But we are doing that. That is currently what we do.
Yeah, that's a great way to put it, right? You can just see exactly where every atom in a protein is.
Yeah.
Given that you can't even see a protein yourself
Right.
now, it's a pretty amazing thing
So
to be able to
it's
do,
way
right?
better than X-ray vision. It's like you can't just see through the wall. You can actually see electron density of all the atoms.
That's cool. So, and Alex, you're going to, knock things together and create fusion and save the world's energy concern. But the work you're actually doing, I mean, describe what you're actually trying to accomplish and do.
Of course. So I work on fusion energy. So the idea is we have this idea of fusion where you take two hydrogen atoms and you fuse them into a helium, and that actually releases more energy than that fission reaction I was talking about earlier. And instead of making nuclear waste, you're making helium, which we're running out of anyway, so might as well start making it. And we know this happens because we can look up in the sky and see the sun doing fusion all the time. So the plan is to bring that process to Earth, and in doing so, we make a big magnetic donut where we wrap magnetic field lines in a donut so that the hot plasma can't get away because there's no substance in the universe that can take the heat needed to make it. So on the sun, it takes about, I think, 10 million Kelvin to do a fusion, but they have an intense gravitational field, and that helps them out a lot. So we need to be 10 to 100 times hotter than that to do it on Earth. So we need to make what we call a magnetic bottle to contain all of that. And we do that every day up in La Jolla. And hopefully someday we can make it cost effective and make more energy than it takes to start. So right now it takes more energy to put it in and make this incredibly hot plasma than we can pull out of it. But there's a project called ITER, which we're building in France, and the plan is that will be the first time that we'll ever make more energy from this reaction than it takes. And that could potentially be the ultimate source of clean energy.
Ooh, nice.
Which is awesome.
what's that address again that we, up in La Jolla?
Up in La Jolla? You can get a visitor pass
Is it
and go
by the
check it out.
Children's Cove there?
Well, and Dina, you're literally changing one cell.
So
into
yes, I'm
another.
sure that you've heard of stem cells before and how you can use stem cells to make any type of cell. Well, we can also make stem cells, again, from fibroblasts, which are a type of connective tissue in your muscle and under your skin. And you can turn those into stem cells called induced pluripotent stem cells. However, that's not what I do. We go, and you can take those stem cells, you can make things like neurons, but what we do is we just take the connective tissue, the fibroblasts, and turn those directly into neurons. And there are reasons we do this. The lab that I'm currently in is studying Alzheimer's disease. If the one thing that you probably know about Alzheimer's disease is that old people get it. So when you make a skin cell into a stem cell, you rejuvenate it, you make it young again. When you're studying a disease that is so closely linked to age, you want to try and make a neuron that's old rather than make a neuron that's young. So we can take the fibroblasts and turn them, and using this virus to give them neuron transcription factors and turn them into brain cells, we make brain cells that look old as if they came from the patient at the same age. And so that way we can model Alzheimer's better than with are more in certain areas of Alzheimer's, looking at the age factor, we can look at it rather than using stem cells, which erases it. So.
Yeah. So, yeah, exactly. So you kind of already got here supervision, right? Super control over matter itself, transformational powers there. We're talking about, microbiome itself, which is frickin' awesome. If you have not looked into this stuff, not the, there's a lot of people who will sell you all sorts of stuff on it, but the research that's going on and what's coming out and what our completely different understanding of how our bodies work is pretty cool. And the notion of what I eat may affect what I think.
You are what you eat to some extent, yes. And the more we realize that we've been ignoring these microbes that have been co-evolving with us for so many years, they do a lot of things for us. I think the simplest way to think about it is, if you think about cows and how cows eat grass, they normally can't actually digest that grass. It's microbes that do it for them. And we have plenty of those in our body that do tons of things for us as well, and they secrete molecules that we use for energy. They have molecules that change how our genes are expressed. So we're learning more about how about 3 pounds of microbes, which are actually more cells than your number of human cells, and way more genes than your number of human genes. There's over 200 million microbial genes that live inside of you, and only about 23,000 human genes. So you're actually more microbe than you are human, if you think about it that way.
You take
so
that back.
they're taking over, and are we really just like a spaceship that drives around microbes all the time?
So have you found the midichlorians yet? Yeah. Because when you do, let's find a cure.
Right?
And then what we actually have is, you spend a lot of time, right, Michelle, in biotech, right? Taking all this stuff and actually turning into a product that
Right, does
actually makes
things.
it.
Yeah, so some of the things that I've worked on, in addition to the tumor regression, completely different. I worked on a extremely sweet protein. This protein was so sweet that just a little drop of it, which we tested in the lab with our own tongues, it would blow your mouth out the whole day.
I'm not sure we can allow that in the future.
Can I get some? I volunteered
That
to
was
be
the
on the
only-
next
I wanna try
test.
this.
Right. We didn't have a really good assay to determine the concentration and the function of it. We'd been genetically modifying it, so we didn't know how sweet the protein was that we ended up with. And we tried to use other kind of taste buds. So at some point, we ended up ordering, like 10 pounds of cow tongue. And it was in the freezer. And I asked my boss, I'm like, there's this box labeled cow tongues. I'm thinking it just stands for something else, And he goes, no, those are really cow tongues. Why do we have 10 pounds of cow tongues in the freezer? Oh, well, we wanted to use the taste buds receptors. And well, we found out that these particular taste receptors don't work on a dead tongue. It has to be, it has to be a live tongue that can actually taste it for the senses to work. So we never actually came up with a really good assay to determine sweetness, but my tongue did get a lot of practice.
What do you do with the extra tongue? Heard it's cow tongue tastes pretty good. Did you take it home?
Did you make some tacos?
Oh, it was a sweet protein, so we did a lot of baking.
Oh no, with the cow tongue. Did you get to
With the
take
cow
that
tongue.
home?
Oh, the cow
That's
tongue?
delicious too.
Oh, yeah, yeah.
No.
So there we go. A whole range of scientific superpowers, and of course, Todd's going to keep us all safe and keep them from becoming supervillains. Because that's the last thing we need, is they're too smart for that, and that would be a bad thing for us. So we got some time left here. Let's turn it over to any questions we've got from the audiences. If you've got a particular superpower you'd like them to work on, I'm sure they could come up with some experiment to engage you with. We got a mic right here.
I have a quick question. So I know with a lot of rules, it's the first person it did is the reason it's on there. So what was the superpower for the person who actually had the silica dust that they always include that says do not taste or do not eat?
Todd, what was the question? He's asking me?
That one might have been self-explanatory. I don't know, but
I cannot confirm nor deny that answer. Sorry.
It's forbidden food.
Actually, I'm trying to pick a question. I work at Berkeley Lab. So if you're ever in town using the ALS,
Love ALS.
look me up. I'm an
Love
EHS. So since I have access to both the 88-inch cyclotron and the ALS, which one would be better for me to put, say, an ant in and get its superpowers?
So ALS or what?
Or the 88-inch cyclotron?
I like ALS. Because I've been there more.
Please do not kill us with your giant ants.
Hello, I'm an elementary school teacher, 4th and 5th grade, and I would love to hear from the professionals. What are the must-dos as far as science safety that any citizen scientist should be following whenever they do an experiment or an investigation?
Don't taste anything.
No mouth pipetting.
Protect your eyes.
Yes, eyes.
That's actually a pretty good one. The mouth pipetting thing was in fashion until at least the 70s, if not later, where scientists would just use it like a straw to suck up whatever it is they were dealing with. Oh, we don't allow that anymore. There are a couple of answers to that I would have. Is one, you should always be using some sort of a mechanical structure to provide safety to you. We use fume hoods and so forth to protect you, but that's not always possible. And then the fallback is always personal protective equipment. You always wear safety glasses, you always wear gloves, you always wear a lab coat. And that's the most general rule of thumb, especially for kids coming up.
I think when they're actually in the 4th and 5th grade, also learning things that you should learn in kindergarten. Don't throw things. Don't chase anyone with sharp objects. Those all still apply to all parts of science.
Have you met my mom?
The sharp objects thing I agree with. I think the closest I've come to some sort of accident is I've been using scissors and I cut my glove open a little bit, but not my skin. But then, I think that Sharp's safety is one of the top ones. And yeah, the personal protective equipment. When I'm working with virus, we get the extra personal protective equipment. We put on our lab coats, our goggles, and then we put extra things over our lab coats, and we wear face masks because you don't want to even breathe it in. So.
And every year, Todd makes us watch hours and hours of videos so that we don't do those things.
What is it? Red Asphalt and Blood on the Highway. Still two of my favorites.
So Dr. Gunn, there's one thing you said that I noticed. You said you used to go to the synchrotron directly, but now you can remotely ship your crystals. And I thought that might be a source of a superpower, because the crystals are proteins, and if you can tell those proteins to hook up, then you could come up with some interesting effects. So I was wondering if you could work with that.
Yeah, so we ship them in these dewars, liquid nitrogen dewars, and there are robots actually at the synchrotron that pick up each pin that has a crystal at the tip of it. So yeah, they could probably have a party at the synchrotron and come up with a new function, I think.
They hook up with the mice, and then we're all in trouble, yeah. And the ants, yeah.
So many superheroes, such as the Flash, have rapid regenerative healing, and I was wondering what your insights are into where the research stands on the rest of us having similar powers, and when can I have that, please, soon?
Well, I already mentioned that we can make skin cells, which you're constantly generating skin and connective tissue, you can turn those into stem cells, which you can then use to turn into anything that you want. So I think that's as close as we're getting right now to like the super healing factor.
You've probably also heard of some biohacktivists that are using CRISPR on themselves. I don't recommend it. But there's some interesting technologies now that we're using that we can manipulate DNA, and it's amazing how you can change something you can't even see. But we have all these cool ways of actually seeing it by putting it into programs and visualizing it that way. Otherwise, it's a lot of colorless liquid.
Cool, thank you.
Good evening. So I'm a clinical laboratory student by day and a doggy daycare attendant by night, two very different sort of callings. And I'm trying to write safety protocols for my layman coworkers, and I'm having a real sort of trouble connecting like my OSHA CLIA training to like non-science-minded people. And I was wondering if you have any experience taking your sort of safety precautions and translating it into a sort of layman work environment.
A big stick.
A big stick.
I'm not sure there's a good answer to that. It is very difficult. But the really, really smart people you deal with can also be very, very difficult. So it's you know, it takes practice, and you just try to make it as focused on the crowd that you're trying to teach as you can. But I don't have any good one-step, two-step processes for doing that. Apologies.
Do dogs count as sharp objects?
Would you say fear? Scare them?
We have a lot of undergrads come through our lab, and like guaranteed the undergrad's gonna set something on fire or break something really expensive the first day. So I have a binder with lots of pictures that have like no signs on it. Don't touch this, don't do this. Pictures seem to work pretty well.
I think one thing with lab safety that gets confusing is like every bottle, every chemical you pull up has like all these hazard symbols on it, even if it's like sodium chloride, right? Water. And so I think focusing on like the priorities, the most important thing, emphasizing that over and over. The things that can slide, you know, so, you know, you just emphasize the most important ones.
And perhaps what they're paying the least attention to, and really finding out what's important to them to do their job, right? They're not so worried about safety because they're trying to do their job. What parts of the safety are really critical for them to do a good job, right? And keep everyone safe.
Thank you.
Out of each of your respective fields, which do you think would be easiest to give someone magical wizard powers?
Did you say wizard? Wizard powers?
Wizard powers.
Wizard powers.
I think my vote goes to Robin, or
Yeah.
maybe Alex.
Wizard powers.
Wizard powers.
I want to be a
You're
wizard.
manipulating matter, right?
Right.
I guess that's kind of wizard-like, but
Sometimes
there's a lot of
be
circuits
yours.
to do that.
Yeah.
Yeah.
Sometimes I feel like I'm doing like alchemy, kind of like Full Metal Alchemist style, because I'm turning one thing into
Yeah.
another.
Yeah.
Same.
Kind of feel like
Through
a bit of a wizard.
Yeah, if you covered
Thank
up all
you.
the
Help me
circuitry, you
choose
could
my
call it
major.
wizard powers.
I would suggest going into the arts.
Hello. So I guess this is more like a chemistry-based question. So one of the most classic falls that has happened is the Joker, or who would become the Joker, falling into a vat of chemicals, which, as we know, turns him into this villain. I'm sure it's very possible for someone to fall from, 20, 30 feet into liquid and survive. But how, in your opinion, would chemicals affect? Is it possible for someone to be submerged in chemicals and that somehow affects their psyche? Because it wasn't just the guy's face that changed, his mind changed. He apparently went, off the deep end. So what could chemicals do that and change someone's personality if you're submerged in it?
I would say that any major accident that disfigures you could affect your psyche. I wouldn't say that the chemical itself would, but I'm sure there are things like, what is the mercury? Mercury is something that back hundreds of years ago people used, and if you got it into your system, it made you go kind of crazy because it would affect the neurons. So
Or leaded pipes. All of the
heavy
pipes
metals
used
in
to be-
general might affect the neurons more than other parts.
Well, they definitely knew that mercury affected your brain because they would actually use it as medicine to treat mental illnesses.
Thank you. Thank you.
Which we know now does not work.
Not so good.
Okay, so I'm hoping you can solve a childhood mystery for me. I was promised superpowers, and they have not arrived. When I was a kid, I had a whole ton of x-rays, and my father said, if you have any more x-rays, you'll start to glow in the dark. Well, time has passed, and I've had lots more x-rays. So when can I expect the promised glowing to occur?
I like
I think a couple of us have a virus that could speed up that process.
I think you might have to come to one of our labs and we can hook you up.
That's sort of a myth. As was mentioned here, the shrink-off radiation actually occurs when a particle moves faster than the speed of light in a medium. So it can glow in a substance like water. You'll often see when they've got a radioactive source at the bottom of a well, you'll generate this glow. And it can even happen in air when there's moisture in the air. But in general, X-rays don't cause anything to glow other than in comic books. So, sorry.
I am a veterinary technician. I have violated a couple OSHA rules. Sorry. But, like, nothing bad happens to me, luckily, yet. But,
Yeah.
Alex, like, your thing, if like, you violate regulations, what happens if your magnetic bottle fails? Like, do we have the power of the sun here on Earth?
So you're asking what would happen if
Like, somewhere someone does not follow rules and your fail-safe fails.
So fortunately, there's a thing called the ideal gas law for us, where if a gas expands, it cools off, and it's really hard to get this thing hot enough to fuse. So if we ever did have fusion and, say, the plasma hit the wall and melted a hole, it would cause the gas to expand and cool and then quench the reaction. So you don't have to worry about a nuclear meltdown with that.
We're good. All right.
Still, you want to avoid La Jolla.
It makes me feel better because I work next door.
Yeah.
You'll be good.
All right, so this is the last question I'm being told, so I got a good one.
So there are a lot of super powers that come from lab accidents that use it as a big hand wave for like, oh, it's lab accident, that's why. So like the Spider-Man and the Hulk. So what OSHA regulations should have stopped that from happening in the first place, what do you think?
Both of those took place before OSHA, so we're okay.
Well, the current Spider-Man doesn't.
So
back when it was
see.
invented, it did. What about now?
Yeah. First of all, the Hulk, I think we kind of discussed the way things were back in the military. They weren't too concerned with safety at all. I would expect that in most cases, if a person is in an area, the experiment can't happen.
Right.
There are fail-safes set up so that if a door is open or if you drive out onto that missile range or whatever was happening in the Hulk, it would automatically shut down. Most laboratory research settings are set up like that, X-ray diffraction units and so forth. You can't get to it while it's on. Spiders?
Well,
I don't know how you prevent a spider.
We were talking about mice escaping pretty easily, and
ants
spiders,
getting
baby
irradiated
spiders, are
and-
even smaller than baby mice. So.
We'll have to write OSHA.
So it's
So-
still a possibility, you know. That's the good news.
Don't get your hopes up, Deku. I see you there.
All right, so let's take a chance to thank our panelists for their stories and insights. Thank you all for coming out. Have a good rest of the night and a great 50th Comic-Con. Enjoy San Diego.